Alright, let's do some more examples. In this one, you can see we have a couple of things that are being multiplied. This first factor here, though, is being raised to the third power, so I'm going to go ahead and distribute my 3, my exponent, through those. There's no exponents or anything like that on these two remaining ones, so I can actually just drop those parentheses. Alright, let's see. -4 quantity cubed, that's a negative repeated 3 times, so it's going to still be negative. And we're taking this, raising it to the third power, so 4 cubed is 64. A cubed. The b, well, actually, let me just write this out like this first. Don't want to do too many steps at once. Alright, so this opposite of b right here, this I'm actually going to think of as a -1 times b. I'm kind of separating off the exponent here. I mean, I could just say it's a negative and we're going to have the two negatives cancel out, but I'm doing it this way so I can kind of more easily think of this coefficient as moving around, the same way I've been moving around coefficients on the other parts. So in any case, -1 times -64 is a positive 64. We have a cubed, we have b times b, which is b squared, and c squared. Alright, the same things, even if we have fractions, this doesn't really change much of anything. We'll do 4/9 times, well, 27 halves. I could go ahead and push these together as the same fraction. The nice thing, the reason I might do this is so I can more easily see what cancellation I can do. I'll deal with the cancellation in just a second. I'm going to just rearrange things. I was able to just move those around because I was ignoring these parentheses, those ones and those ones, since there's not anything going on there. These parentheses I can't just ignore. I need to deal with the fact that it's raised to the second power here. So we're going to have, let's see, the opposite of a squared, and b squared. Actually, I'm doing this in a weird order. Let me just start that over. Let's do 4/9. Let me just deal with the parentheses first, because I don't want you guys to get confused with what I'm doing here. -a squared, squared, b squared, and then 27 halves, a squared, ab squared. Okay, so I moved the fractions together. So we get 27, or 4 times 27 over 9 times 2. I'm intentionally holding off on actually multiplying those together because there is some cancellation I can see. There's a factor of 9 I can cancel there and a factor of 2 that I can cancel here. So when I cancel the factor of 9, a 1 is left behind here, and we get a 3 left behind up here. When I cancel a factor of 2 here, a 1 is left here, and a 2 is left here. So 2 times 3 is going to end up giving us 6. And we have a 1 in the denominator. So I don't need to write anything for the denominator since it's a 1. Let's see. I should probably deal with this other stuff, though. AB cubed, there's nothing to deal with there at the moment. This opposite of a squared and then squared, this negative occurs twice because of this, because I'm squaring it. So this will end up being a positive, just getting rid of the negative. And a squared squared, this is going to give me a 4 because I'm taking 2 times 2. Notice that's not 2 plus 2. I guess you could call it 2 plus 2 if you're, whatever, if you look at that slightly differently. But let's see, then a b squared. Okay, so the rest of the stuff I just copied down. Now let's see, we'll finish this up. A times a to the 4th times a, that's 1 plus 4 plus 1 is a to the 6th. And for the b's, with b cubed, 3, 2, 2. That sums up to 7, so this would be b to the 7th, and that would be my final answer there. On this one, we have, it looks like the 4y quantity squared, so I have a product raised to a power that's going to be 16y squared, and then I have y cubed to the 5th. This is going to be y to the 15th. Alright, I can take one more step to clean this up a little bit more. I can take the 2 and the 15 and add those together to get y to the 17th. So I'm kind of, I used all 3 properties, all 3 laws of the exponents on this one. I used the fact that I have to distribute my square through the parentheses, 16 and the y squared. I'm doing a repeatedly raising to a power. This is sometimes called the power rule. And then we have the same base multiple times in a product, so I end up adding the exponents there.